Hi, I'm Kevin.
And Rahul.
This is our CS2316 project, and we're analyzing car reliability. We wanted to identify the most reliable vehicles by analyzing three key metrics: recall rate, sales performance, and crash rate. By combining these data points, we can discover which vehicles are the most reliable. We chose this topic because we are both interested in cars and we wanted to learn more about the most reliable cars, brands, and models. So these are our data sets. The first data set is our CSV file that we found from data.gov. This data set lists key recall details: manufacturer component, severity, and vehicles affected. This helps us spot reliability and safety issues and can be paired with sales or production data for a more accurate comparison. Our next one is an HTML file that we found from allensfactoryoutlet.com with a table. This dataset shows the best-selling U.S. car models since 1978, revealing long-term trends in consumer demand and brand dominance. This can be combined with both of our files for deeper context. Our third one is the JSON file. This dataset captures crash details, make, model, severity, in which cars are face more frequent or severe accidents. This can be used when being paired with recall and safety rating data. This was found on data.gov. And as you can see, we cleaned our files and this is what it looks like here. On to the data cleaning.
Okay, so for our downloaded data set, we found a data set on data.gov. This was the recall data set. So we converted it from a CSV to a data frame here with the pd.read CSV. And then any empty completion rate would be replaced with the average completion rate. And then we did a bit more cleaning. So we made sure the recall type was always vehicle. And if the campaign number is unknown, we replace it with unknown. And then we just export it to a data CSV and then return the dataset.
For this web collection number one, we found the dataset by searching for the most popular cars on the internet. We scraped this website's table by using Beautiful Soup. We extracted the year, model, units sold in each row, and we separated the year and model into two different sections because on the table on the website it was only one section separated by a comma. And we saved this clean data into a CSV file. So in this code, we created different lists and we basically looped over the whole table, finding all the data and exporting it into our list that we have here. We appended years and car model, which were originally together, and also the units sold.
All right, for the second web collection, which was the JSON dataset, we also got it from data.gov. So we requested the site, got the JSON. We filtered through the metadata in the JSON to get the actual data we wanted. We turned that into a data frame, specify what columns we wanted, and then we replaced all the empty cells for make, model, and year with unknown to specify that we didn't know the values for that. And then we exported to a CSV and we turned the dataset.
On to our insights. So for insight number one, this was pulled from our HTML source, and this uses linear regression on Sklearn to analyze how car sales have changed over time. So we in this code right here, we use 2021, but you can really predict any year that you want based on the data that we have. And this shows whether sales are increasing or decreasing by calculating the yearly change. So we have two variables, year and units sold. We use linear regression. We fit it into the model so the model can learn, calculates the slope and y-intercept, and that basically gives us the year that we want to predict. For insight number two, this was also from the HTML source, but we basically calculated how reliable a car is based on the score that we created. So it measures average sales, sales stability, years active to measure the long-term performance of each car. So what we did here is we encoded each car into numeric values so that the machine can actually use them. Since when we first did this, we figured out that our table had a lot of strings and it couldn't read strings, so we had to make them into numeric values. And after that, we trained them into random forests to generate a reliable score for every year based on these features. What is happening here is we basically made decision trees to find out which cars are the most reliable by combining disjointed data and squishing it down to a more reliable data. What happens at the end is we return the top 5 most reliable models of cars.
All right, so for Insight 3, we pulled the data from the clean car crash CSV. We did some filtering and we made sure that the column's case was consistent. And then we made a pivot table with the index of the specific vehicle, make, and model. And we did it based on the damage extent column. So as you can see here, we have our specific make and model, and then the counts for each extent of damage. So as you can see for this Toyota Camry, the most common extent of damage was disabling to the car. And then as you can see here, we have the total amount, so you can get an idea of the proportion. Okay, so for Insight 4, this one's also from the Clean Car Crash CSV. So what we did here is we cleaned the data once again. We turned the Boolean values into integer values so we could calculate a rate. And we calculate all the rates here using group by. And then we got rid of any of the values that had a crash count less than 100 because they're insignificant. So as you can see here, we have the vehicle make, the total amount of times it appeared, so the crash count, and then the rate. So the rate, it was rainy or wet, the road was wet, or it was dark, and then we also have the average speed here. And then for Insight 5, this was from the recall dataset. So we pulled data from the clean recall dataset. We grouped it by manufacturer, and then what we found was the total amount of recalls, as you can see, total amount of cars affected, and then the average amount of cars affected per recall. And then we got rid of any insignificant, so ones with recall counts less than 100 because they wouldn't really help us that much.
Onto our visualizations.
So for our visualization, for number 1, we did it based off Insight 3. So we wanted to see the proportion of damage types for each vehicle make. So we made we summed up all the vehicle makes. We made the damage, or we made the data vertical so it'd be easy to graph over here. Then we graphed it, made it easy to read, so we stacked the bars, and then we made the labels angled so they wouldn't jumble up with each other. And then we show it here, and then we export the image. So as you can see here, you can see the proportion of like what type of damage is most common. So it seems like superficial damage is pretty common over here, as well as disabling.
For visualization number 2, this goes hand in hand with Insight 1, and this plots a line chart showing how units sold changes from 1978 to 2020. We used markers and formatting to make this trend easier to read, and this basically shows the sales pattern over time. So we use a line chart here, we marked X and Y's, and then where it says update traces, this basically adjusts our lines and widths for more aesthetic purposes. And at the bottom, we had to tilt the years to the around 45 degrees for more visibility here. And this, we can see a trend in cars going up or down, and this can be complemented with other data.
All right, so for visualization 3, we did it based off the data from Insight 4. So we took all our rates and we made what is called a polar graph, which we found on the Plotly documentation. And it's basically like a sort of stat graph. So as you can see here, it shows the trends towards each rate. So it seems like it's pretty common for almost all car makes to have a high crash rate during dark times, and then sort of mid during rainy times and like wet road conditions. And yeah, so that's basically what we did. We took data, we graphed it, we showed it, and then we exported the image.
In conclusion, our project shows that the most popular cars are not always the safest or most reliable. Some models sell extremely well but show weaker reliability or higher crash severity, while other brands that sell less often actually perform better in stability and safety. By combining sales data, accident records, and prediction models, we were able to clearly see which cars stay consistently strong over time and which ones struggle. Our analysis helps connect how cars are marketed and how they perform on the road and how consumers respond, giving a simple but meaningful picture of the real differences between top selling, reliable, and safe vehicles. Thank you.
Thank you.